Okay, there's no like difference, but you just have to understand when I say chemical equation, what are we referring to? It's like we are referring to, even if you don't define it, just tell me what a chemical equation represents, right? It represents a chemical reaction. So this chemical equation is the one that will represent a chemical equation. You understand that, partner? A
Yes.
chemical reaction. Okay, so let me give you an example of a chemical reaction. What do we mean by a chemical reaction? So a reaction is when sulfur reacts with oxygen to form sulfur oxide, sulfur dioxide. Are you listening?
Yes.
Okay. So one thing you're going to find in an exam, they'll give you what we call a word equation. So you need to be able to transfer from word equation to what? To chemical formulae equation. So a word equation, we are saying that sulfur, it will react with oxygen. So when sulfur react with oxygen, the product will be, we use an arrow in chemical equation to show the product, okay? So the product will be sulfur dioxide, sulfur dioxide. So one thing you need to do, you need to be able to differentiate between, if I say sulfur, this is what we call a word equation. You need to be able to take this guy and write it as what? Chemical. We need to write it as a chemical formula. This is an easy thing to do. A chemical formula equation. Tell me, what is a chemical formula for sulfur?
Mm, could it be
Exactly.
SO2?
Yeah, it's just X. So it will be S plus for oxygen, that's O2 because oxygen is a diatomic. You understand? That's why we are saying sulfur dioxide. So sulfur dioxide, it will be SO2. Then this is what we call the chemical formula equation. Okay?
Yes.
Okay, so now when you look at this guy that we have, I'm going to divide this into two parts on the arrow. Okay, so
Yes.
I have the right and the left hand side. This is my left and this is my right. So from this, I need you to note that whatever that the chemicals that react are shown on the left side, we call them the reactants. You understand that?
Yes.
And the chemical that are on the right side of the arrow, we call them the products. So if I ask you, what is the reactants in this chemical formula equation? We're going to say sulfur and oxygen are my reactants. You understand?
Yes.
Okay. Then when I ask you, what is the products? You're going to say sulfur dioxide. Are we good?
Yes.
All this that you see here, it's a chemical. It has to do with chemical equation. So if you understand this, now you know what is a chemical equation. That's the first part of this lesson, okay?
Yes.
Right. So now we're going to move to the next part. The next part has to do with balancing a chemical equation. You need to be able to balance a chemical equation. Okay, right, 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 right. Uh, when we do the balancing chemical equation, there's a law that we need to revise. This law has to do with what we call the conservation, the conservation of uh, atoms, the conservation of atoms. So this law says that atoms cannot be created or destroyed. So I'm not going to write this down there. You know why?
Yes.
Because they will never say define conservation of atom in an exam. I'll give you the ones that you need to understand. So I'm just going to put it up here. But this says that atoms cannot be created or destroyed. So tell me, according to this statement, what do you think we are referring to when we say atoms cannot uh, be created or destroyed? What is your understanding on that statement?
So I feel as though when we are given a equation to balance and we need to move uh an atom, no, not an atom, uh or something somewhere, we can't just get rid of it because it's an atom. So it must go somewhere, or we must move it to a different point instead of completely just disappearing it because it can't just disappear.
That's what I'm looking for. Disappearing or appearing, you understand? So let me
Yes.
just help you understand it uh, very well. So if we go back to this conservation of atom is like saying, if we look at this sulfur, we only on the reactants. So we have the reactants and the product. So for sulfur, we have one sulfur, one atom of sulfur. So this tells you that even on the product, it should be one. Because if we have two, this tells you that we created another sulfur. So we cannot do that. If we go to oxygen, the subscript to there, it tells you that there's two in the reactant. We have the same on the product, so there's two. So can you see that we have one on the reactants for sulfur, one on the reactants for the product. So this tells you that atoms cannot be created or destroyed. You can't start with one and then you end the reaction with zero. Impossible. You can't start with two of oxygen, then you end with one. You need to make sure that you balance your equation. If you have two this side, even on the other side, you need to have two. Is that making sense?
Yes.
Okay. Now, uh, to conclude this conservation of atoms, what we are saying is that in a chemical reaction, all atoms that we start with, which are the reactants, will still be there at the end. At the end are the product. So we started with one sulfur. When we end the reaction, we should end the reaction with one sulfur. Is that making sense?
Yes.
So an equation will be balanced when the number of atoms of each element on the left is equal to the number of atoms of each element in the right. Then we say this is balanced. So to balance the equation, we're going to use what we call the coefficient. So the balancing number written in front of a chemical equation, we call it the coefficient. So if you look at this guy here, sulfur is just one. You don't have to write one, but we know that there's one there. So this one, we call the one the coefficient. Do you understand?
Yes.
They won't ask you to define what is a coefficient. You just have to say, you just have to know the coefficient is the number that we're going to write in front of a molecule. You understand? So let me
Yes.
write this down. The coefficient I think chemistry is also one of my favorite topics, but I mean favorite subject. It depends what type of chemistry that we are working on. This one, I really like this one. It's just written for. If you look at the coefficient, so if I write uh, 2SO2, so the 2 in front, that's your coefficient, right? So the coefficient, it indicates the number of, okay, let's write it down. It indicates the number of molecules. It will indicate the number of molecules. Are you following?
Yes, sir.
So it
But so how do
indicates,
you how, oh,
I'm listening.
yes. No, I'll ask you at the end. It's okay. Carry on.
Okay, please don't forget. Ne?
Yes.
It indicated the number of molecules that are involved in a reaction. So if I write it like this tells you that there's 2 of sulfur dioxide that we got at the end. Okay, so if it's 1, you don't have to write. You don't have to write 1 SO2. You understand?
Yes.
Okay, so now let's go to the part, the very important part. When you do chemical equation, you need to understand what we call the state symbols. So on the state symbols, this one is the state symbols, they will indicate the physical state or the phase of the substance that the reaction at the reaction temperature. So we're going to write them as what we call the postscript in brackets. For example, I can say I have hydrogen in gas state. And then now you see this small number that you see here, this part here, it's a state. We write it in what? We write it in postscript. I hope you understand, and it should be inside the bracket. Usually, it's included in the balanced equation. So now I'm going to give you the state. We're going to use G. This is for what? What is G for? What is the meaning?
Gas.
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 And we have S, which is the solid. And we have this one, which is the liquid. 100%. Can we move now?
Yes.
Okay, so now I'm going to give you, we're just going to do an example on balancing the equation. Then when we're done with balancing the equation, I think, okay, then we can move to the next part of the chemical chain, okay?
Yes.
100%. So now when we balance chemical equation, let's say we have nitrogen, which is N2, it reacts with hydrogen. Then this gives us ammonia, which is NH3. So now, nitrogen react with hydrogen to form ammonia. Write a balanced chemical equation for this reaction. They say write balance. Let me not write everything down just to save time. Yeah? So let's balance this equation. How can we balance the equation? So when you balance the equation, I'm going to first, to balance the equation, let's check the atoms of the one with one element. You start with the one that has one element. You understand? So for
Yes.
example, this one is, let's say we can start with nitrogen because also has the one element. So uh, we can start with 8 atoms, it's fine. Always start with the one that has one element. But in this case, all of them, they just have one element. But now let's try and check. So when you look at this 2, it tells you that we have 2 nitrogen on left, the left side. So we have 2 of them. So since we have two of them, then if you look at this one, we only have one nitrogen on right. That's where you start. You need to balance this equation. So if we have two this side, I can just put the two here. So when I put the two, look at this now. We have two this side and also two on the reactants. Can you see now? This is balanced.
Yes.
You see that part, okay? So now
Yes.
the nitrogen is balanced, then you move to the next atom. What will be the hydrogen? So if you look for the hydrogen, I can see that for the hydrogen on the reactants, how many do we have? There's only one, right?
Yes.
Okay. I'm sorry, there's two.
Only two.
Yes,
Yes.
there's two H on left and look at on the right. I want you to tell me how many do you have on the right?
Three.
Is it three?
Yes.
Are you sure?
For hydrogen.
Yes, hydrogen.
Sir, is that not three? Or am I doing something wrong?
I think you're going to learn something new today, Ned. You see these two.
Okay.
These
Yes.
two is for both N and H.
Oh, left. Sorry, I was looking at the right. Sorry.
Yes, this side is two,
Yes.
and then this side, it can be 3 for nitrogen, but it's 2 times 3. You multiply the numbers because the 2 is for the N and it's also for the H. And then you're going to multiply the 2, which gives us 6. So we have 6H on the right. So to balance this equation, we can multiply this 2 by what? By 3 to get 6. So I'm going to put 3 here because if I say 3 times 2, this gives me 6, this gives me 6. Then the equation is balanced.
Oh,
You
I see.
understand? Then you need to,
Yes.
when you give your answer, you need to include the symbols, the state symbol. So nitrogen, that's a gas. And then hydrogen, that's also a gas. Then they give us ammonia, which is also in gas state. So this is 2NH3. So the equation is balanced. Can we move to the next example?
Yes.
Okay. Uh, okay. We'll keep on doing balancing the equation. The next part, uh, let's balance this last one, then we'll move to the next part of this lesson, which is also very, very important. So let's say you are given methane that burns in air to form carbon dioxide and water. So methane is CH4 and O2. It burns in air to give us the carbon dioxide and water. So if we balance this equation, I'm going to check. Remember, we said we start with the atom that has one element. So I'm going to check the atom of one element. For example, you can do for C, uh, you could have started with other elements. Right. So let me start with C. How many carbons do we have on the left? On the
One.
reactants, how many? Let me say
One.
left and right. So we have one. Then let's count. How many do we have on the right?
One.
One. So carbon is already balanced. Okay.
Yes.
Okay. So now I'm going to check for H atoms. So if I check H atoms on the left, how many do we have?
Four.
Then on the right, how many do we have?
Two.
Exactly. So to balance this equation, what should we do?
Uh, can we make times? Or can we divide?
Look at
No.
this. Listen, we have 2 on the right. We have 4 on the left. How can we get 4 on the right?
Times by 2.
Exactly. You're going to put 2 in front of that 8. You understand?
Yes.
So now we have 4 on both sides. So now it's balanced. You understand? It's because there's 4.
Yes.
Can we move to the next atom, which is
Yes.
oxygen, the last one? So for oxygen, if you look on the reactants, how many are they?
2.
2. You write 2. Then for the products, how many are they on the products? Please be careful now.
Yes.
How many are they?
Can we say 3?
Why is
Because
it
that
3? Because remember I
could.
said that 2 also apply to that O. It also apply to this H.
Okay. So the oxygen on this side, on that side, is also 2.
Why is it 2? We have 2 this side, and the 2 applies for that O, meaning we have
Oh,
another
so
2, that's 4.
yeah. Sorry, I was trying to say that that 2 that you're that O that you're pointing out also has 2. So there's 4
There's 4. So to balance this, what should we do on the left?
times by 2.
Exactly. We're going to put 2 in front of that oxygen. Can you see how easy it is to collect this marks?
But can we not? Are we not supposed to put? Oh, never mind. Never mind. I understand.
All good.
Yes.
Okay. So now that you understand this, let us move to the next part of chemical change. This was balancing equation. I'm going to give you a work maybe during the week or during the weekend to practice balancing equation. So now that you understand how to balance equation, we're going to use using the molar mass to show conservation of mass in reaction. So I'll show you how they ask this question. This one is very important, and there's no way they don't ask you this one. Eh? The conservation, we're going to use the conservation of mass in a reaction. The conservation of mass in a reaction. So now, in an exam, they will need you to tell us that uh, is the mass conserved, yes or no? Support your answer by calculations. Okay, let me do this now. You will be given an equation. Make sure that it is balanced. Okay, let's go back to that equation that we balanced, which was CH4, that is in gas state. Please make sure that you rewrite this equation. You indicate the state symbols. So CH4 that is in gas state is reacted with 2 O2, that is also a gas. And then this gives us a CO2, which was a gas, and also hydrogen, which is a gas. So now, not hydrogen, water, which is liquid state. Né?
Yes.
Water is in liquid state, H2O. That is in liquid state. So please listen. We're going to use the molar mass to show the conservation of what? The conservation in a reaction. Do you know what is a molar mass?
No.
Okay, so let me just do, let's use the molar mass. You'll understand what is the molar mass just in a second. So now, what you're going to do, we need to calculate what we call the molar mass. For this guy, let's start with that guy. You're going to say the molar mass, Mr, inside the bracket, CH4. Then this is how you calculate it. You're going to look for C. on your periodic table, you go look for C. Can you see C there on the periodic
Yes.
table? I'm trying to highlight that C for you. Just give me a second. Okay, so this is your carbon. Can you see that carbon?
Yes.
You're going to take the number that you see, the number below. You see this number here,
Yes.
which is 12, right? You take 12, you're going to write it down here and say this is 12. Then you say plus. After C, you go and find age. Then this is age. You understand?
Yes.
What is the number that you see below?
1.
Exactly. You're going to write 1. But look at this. How many atoms of hydrogen do we have?
Uh, 4.
Exactly. You take the 1, you multiply with 4. I'm just going to put it inside the bracket. So this will be 12. 1 times 4, that's 4. Therefore, the molar mass is 16. So the molar mass of CH4 is 16. So when you have the
Um,
molar mass of CH4 is 16, you need to find the molar mass of what? The molar mass of that O2. You have to find the molar mass of that O2. So to find the molar mass of that O2, you're going to go, you'll go to your periodic table, you look for O. What is the number that you see on O, the below number?
16.
Then you come back this side and say 16. But now, how many atoms do we have there for oxygen?
2.
You multiply this by 2. This gives you 32, right?
Yes.
Listen, listen. Now, you're going to look at the number of molecules. This one has 2, so we need to take this 32 to multiply it by 2. So therefore, the mass, remember, this 16 is the mass of, this will be the mass of the reactants. Then, to find the mass of the reactants, you take this 32, you multiply by 2, which gives you 64. This 64, it's the mass of the reactants. So when you have it like this, you'll therefore find what we call the total mass of what? The total mass of the reactants. It's when you add the 2. It's going to be 32. Oh, I'm sorry. It's going to be 16 plus 64. What do you get on your calculator? 16 plus 64. It's like 6, there's 70, 80, right? So this gives us
Yes.
80. So the total mass of the reactants, it's 80. You understand?
Yes.
You're going to repeat the same process with the products. You start with CO2. You start with CO2. You go to the products. You find the total mass of the product. So CO2, we need to find the molar mass of CO2. So carbon, you go to your periodic table. We said the number is 16. We're going to add this to what? We're going to add this to O2, oxygen, that's 12. You multiply that by 2. Then this will be 16 plus 24. And then 16 plus 24, what is that equals to? Wait, 12 times 2.
14.
12
It's 24.
is 24, right?
Yes.
Let me go back. It's C. Let me go to the periodic table. It's C. C is 12. It's not 16. C is 12. C is the one that is 12. Okay, let's quickly fix this. C is the one that is 12. So C is 12 plus oxygen is the one that is 16, which gives us 32 plus 12, which is 44. So the molar mass of carbon is 44. Then you're going to find the molar mass of the other product. What was that? H2O. You see, the carbon has what? One molecule. So I'm not going to multiply this with anything. Then let's go and check the molar mass. H2O, the molar mass of H2O. So H, that's 1, which we need to multiply by 2, plus oxygen, that's 16. And then 1 plus 2, 1 times 2, that's 2. You add 16, you get the molar mass of 18. So water has the molar mass of 18. Okay, so now remember, water has the coefficient of 2. So this tells you that we have 2 molecules of water. We need to take this 18 and find the mass of this. We need to find the mass of reactant will be, so the mass of reactant, this side will be 18 times 2. So 18 times 2, what is that equal to? 36. This one, the mass, not reactants, products. This side, we have the mass of the product to be 44. Therefore, you're going to find what? The total mass of the products. You know what you need to do, right?
Add them.
You add the 2. 44, you're going to add with 36. So when you add the 2, what do you get? 4 plus 6,
80.
that's 10. 40 plus 30, that's 70, which gives us 80, right?
Yes.
So since the total mass of the reactant is 80 also, we can therefore conclude and say that the total mass before the reaction is equal to the total mass after the reaction. Therefore, the mass was conserved in the reaction. The mass was conserved. So the mass is conserved. So in an exam, they'll say that on this reaction, for 4 marks, show that the mass was conserved, or they'll ask you, is the mass conserved, yes or no? Support your answer with calculation. You start by doing calculation before you can say yes or no. If you find that the mass of the reactants is equal to the mass of the product, then the mass was conserved. If they are not equal, maybe the equation is not well balanced. You understand?
Yes.
Okay, right. I'm just gonna give you something to try. Please, whatever that I'm going to give you now, the work
Yes.
that I'm going to give you, you don't have to share this with anyone. This might get you
Yes.
into like serious problem. These notes are from my work, so I'm not allowed to use these notes to teach other learners. But guess what? I'm just gonna share the work with you, okay?
Okay. Thank you.
When you are done with
Yeah.
this, please make sure that you delete the picture, okay?
Okay.